All right, Emma, here is what we did today in class. So there is in here, kind of hard to see. Let me get. So these are little chips of marble. All right, marble is calcium carbonate, and that may sound familiar because we also said that chalk is calcium carbonate as well. Well, this is not chalk. Marble is very different. It's much harder than chalk. Chalk is powdery. Chalk, like you would use on a chalkboard, crumbles pretty easily. That's a sedimentary kind of rock, meaning it's a very soft kind of rock. That's why we use it for chalk. Marble, on the other hand, is made of the same chemicals, but because it's under, or it has been under pressure and high temperatures, a lot of pressure and high temperatures, it actually reformed that chalk into something called marble. Marble is a rock. We use it for floors. We use it for countertops. Sculptors use it to sculpt statues. So pretty impressive stuff that you could use it for a variety of things, but very different, even though it has the same chemical makeup. Now, the one thing about this is that, let me get the camera a little closer too. One thing about this marble is those little pieces right there. When hydrochloric acid or even any acid goes near it, it's going to start to fizz. And that fizzing is carbon dioxide, and that fizzing is water. Well, that fizzing isn't water, but it's turning into water. And it's also turning those pieces of calcium carbonate, otherwise as marble, into calcium chloride, and it's actually dissolving in the water. So if I poured enough of this hydrochloric acid into this container with the marble in it, I could dissolve all those little pieces. So we have two reactants, in this case HCl, hydrochloric acid, marble, calcium carbonate, and it makes three different products. It makes carbon dioxide, which is a gas, and those are the bubbles, water, which we can't see, but it's making water, and the other thing is calcium chloride, which is the solution it's creating now. It's an aqueous solution of calcium chloride. So I'm going to show you the handout that we were doing in class that kind of sets this all up. All right, I'm going to move this off to the side, try this off a little bit. All right, and the handout kind of looks like this. And it says, write a balanced equation. So we did that in class today. And it has a lot of information up here. I'll just write it and go over it in a second. So it says calcium carbonate, otherwise known as that marble, those marble chips, same thing as chalk, as a solid. When we put it with some hydrochloric acid, HCl, sorry about that. And that is hydrochloric acid, makes three things. It makes calcium chloride, which is aqueous. It makes carbon dioxide, which is a gas, G. And it also makes some water, H2O. And that's an L because it's liquid. Sorry, I had to squeeze everything in here. You know what I could do? I could do it on a big piece of paper. Like this. One more time. So we have calcium carbonate as a solid with some hydrochloric acid, and that's aqueous. And that makes three things. Our carbon dioxide, which is a gas, our aqueous calcium chloride, that's a little 2, and then finally we make some water. Now it's not balanced, so we'd have to balance it. We did this in class, and it's a fairly easy one to balance. I see I have 2 chlorides on the right, CaCl2, but I only have 1 on the left, so this is going to be a 2. 2 hydrogens now, great, because I've got 2 hydrogens over here. Calcium, calcium, carbon, carbon, oxygen. I have 3 over here on this side. Here I have 2, here I have 1, so it's balanced. So therefore, it's a 1 to 2 of the 2 reactants, very important, and it's a 1 to 1 to 1 for 2 products. All right, so that's what we have in terms of the reaction. Some of the information that we have is this. We know we have, and I give this to you on the sheet, so it's right here on the sheet. It's shared with you if you want it. We have 10 grams of chalk, we have 10 grams of marble. We have 3 milliliters of a 1.5 big M solution. right? So the molarity of that. We have why? Because it's aqueous. Solid or mass, so we need its molar mass. So we said the other day, calcium carbonate when it's a chalk is 100.086 grams, and that's equal to 1 mole. All right, so what I want you to see here is this. We have a 2-to-1 relationship between our acid and our marble. We have 10 grams of this with its molar mass. We have 3 milliliters of this with its molarity. Molarity and molar mass are very similar to each other. One is a mole per volume. This one is a this is a mole per gram. Right? So we're both talking about moles here. One's in grams, this is in grams. One's in volume, this is in volume. So what are we going to do with these? Well, we're going to do a limiting reagent problem. And the first thing I'm going to choose is I'm going to choose to do the 10 grams. So we have 10 grams of calcium carbonate, otherwise known as marble. And we're going to set that over, well, if we're doing a limiting reagent, well, we have to think about the 2 reactants. And the 2 reactants, remember, are our acid, HCl, and our calcium carbonate. So in the end, what I really want as my final answer here is milliliters, since that's what the HCl is in. I want to make a prediction of how many milliliters of hydrochloric acid am I going to need to react all of these 10 grams of marble. And how do I do it? Well, I've got to use my molar mass. So 100.086 grams, and that is calcium carbonate. And this one is going to be 1 mole. That's molar mass of calcium carbonate. Next, ratio. And it's the ratio of 1 mole of calcium carbonate, that chalk, to 2 moles of HCl. And then finally, since again, I want milliliters, I'm going to use the molarity of the HCl that I have, which is 1.5. 1.5 big M can turn into moles, 1.5 moles per 1,000 milliliters. In this case, I want the 1.5 on the bottom, moles of HCl, and I want the 1,000 this time on the top. Not traditional way of writing it. This is molarity, but it's just written upside down, and this is HCl. So when I do the math on this, I'm going to get an answer of somewhere around, let me use a different color now. I'm going to get an answer somewhere around 133 milliliters of HCl when I do the math on this. Everything cancels out, right? Yep, and yep. I don't have 133 milliliters, so there's no way that I'm going to be able to react all 10 grams of this. So therefore, I am going to have to do something else. And what I'm going to do then is I'm going to have to do another equation, because right now I know what my limiting reagent is. Remember, I only have 10 milliliters of this. So for me to try to react all 10 grams of this, I'm going to run out of HCl. So HCl must be my limiting reagent. Excess is my calcium carbonate or my chalk. Let's prove this. Well, we're going to prove it by using a lot of the last pieces of information. So, but this time I'm going to start with 3 milliliters of my HCl. And if I'm starting out with milliliters up here, I've got to do something with milliliters of HCl down here, and that is 1,000 milliliters, and this is the 1.5 moles. So this is my molarity that I'm putting in right here. Remember, 1.5 big M. And I'm actually using it very much like how we normally write it with moles over 1,000 milliliters. The next thing I'm going to write is my ratio. My ratio is 2 moles of HCl for every 1 mole of calcium carbonate. Now this, CaCO3. And right here, this allows me to then convert into calcium carbonate, this ratio. And I'm going to use now my molar mass. And I know that 1 mole of calcium carbonate is that 100.086 grams of calcium carbonate. So finally, again, this is going to be a prediction, and it's going to predict how much chalk I'm going to be able to dissolve with this 3 milliliters. So I'm going to cross out my milliliters. Sorry about the sunlight that's coming in right now. Then my moles get canceled out, and I should get something Like, if I'm not mistaken, if I do the math on this, something like 0.225 grams. That means I'm going to be able to dissolve very little of that marble, because 3 milliliters is not a lot when I have 10 grams of chalk, or 10 grams of marble. So this proves to me that my limiting reagent, what I can use all up, is my HCl. So remember, the compound is the limiting reagent. So there's my limiting reagent. And my calcium carbonate is my excess, because I'm going to have plenty of that. Remember, I have 10 grams of that, but I only can use up or dissolve 0.225 by using that 3 milliliters. So we did this in class today, and I asked for homework for people to do 1C, which is find out how many grams of carbon dioxide, one of the products, right? So math means you want to see, find out how many grams of carbon dioxide are produced in the reaction with using your limiting reagent of HCl. Let me know if you have any questions.